Thank you, Nona. So good evening, day, morning, or in the case of our next plenary speaker, Professor Catharine Lovelock, it is actually good night. If I'm not mistaken, it's now 4 a.m. in Queensland, Australia. So thank you so much, Catharine, for agreeing to speak at these hours. So unfortunately, that is one of the setbacks of a virtual-based conference. We are very grateful for your presence here. But let me properly introduce our plenary speaker for today, Professor Catharine Lovelock. Professor Lovelock is an Australian Research Council Laureate Fellow and Professor at the School of Biological Sciences at the University of Queensland. She has received a PhD from James Cook University, Queensland, and has been a Research Fellow at the Australian National University, the Smithsonian Tropical Research Institute in Panama, and the Smithsonian Environmental Research Center in Maryland, USA. She joined the University of Queensland in 2004, and her research focuses on climate change and its impacts on coastal plant communities, as well as the role of coastal wetlands in adaptation and climate change mitigation of blue carbon. She's a member of the International Scientific Blue Carbon Working Group of the Blue Carbon Initiative and leads projects in Australia and internationally, which are focused on climate change, adaptation, carbon sequestration, and restoration of mangroves and other coastal wetlands. She was lead author for the Wetlands chapter for the 2019 refinement of the IPCC Guidelines for National Greenhouse Gas Inventories, and is helping to incorporate coastal wetlands within National Greenhouse Gas Inventories and within other policy frameworks that have the goals of climate change adaptation and mitigation. So please join me in welcoming Professor Catharine Lovelock. Catharine, the floor is yours.
Thanks, Iris. It's almost good morning, everybody. I'm just going to share my screen. So I'd like to say good morning from Gari. I'm on one of the large sand islands on the east coast of Australia at the moment. This is the traditional lands of the Butchulla people. So I need to pay my respects to their elders, past and present. So today my title is Restoration to Address Global Challenges in Aquatic Ecosystems. And as you can see from the slide, this is going to be coastal wetland centric, and often I'm going to use mangroves as my example. But first of all, I just want to briefly outline some of the challenges. And Bo, the previous speaker, spoke about an amazingly important challenge to aquatic ecosystems. But basically, we have changed land use in the catchments. We have converted and overexploited aquatic resources, aquatic ecosystems, and the resources associated with them. And overlaying on this is emerging impacts of climate change. So we know from the very nice work of Halpin et al. That these challenges are having an increasing level of impacts, and that they're cumulative. So if you look at this colour coded vision of the impacts on aquatic ecosystems, you can see that for mangroves and salt marshes, the rocky intertidal mudflats and seagrasses, that these impacts are large and intense. So, for example, for coastal wetlands, we know that they've been converted and overexploited. You can see aquaculture ponds throughout Southeast Asia in what was mangrove habitats. You can see clearing for timber and other things in other nations. And then conversion, the bottom slide, is actually from Australia, where salt marshes have been converted into playing fields and industrial estates and so on. So we've lost probably 30 to 50% of the global habitat. And then there's emerging evidence that climate change is actually potentially becoming even more important than human impacts on these ecosystems. So this is some very nice recent work by Liza Goldberg et al. From NASA, looking at the drivers of change in mangroves globally. And if you look from the 3 epochs here, and the red bars are the human or the anthropogenic changes, and the blue bars are natural changes of erosion and extreme climate due to extreme climate events or extreme climatic conditions. And you can see that, you know, for example, in the high loss countries, so Southeast Asia, that in the 2000s, about 73% of the loss was due to human activities and only 27 due to climatic or, you know, natural factors. But these are approximately equivalent by the time you get to the 2010, 2019 epoch. So these are real and present threats to these habitats. So, you know, the loss is has come about almost at the same time, or, you know, realization of the losses have come about the same time as this idea, or at least the acknowledgement that we get multiple benefits from coastal ecosystems. So these have been, you know, included in the basket of nature-based solutions that we might use to enhance our readiness to climate change. So on the one hand, they're highly exposed and vulnerable, and on the other hand, we're proposing that these are important for services like coastal protection and flood control. So, and then more recently for climate change mitigation, and that's been called blue carbon. So these have been advanced as solutions by all sorts of agencies, and this is the diagram from the bottom of the slide is from the World Bank. So somehow we have to overcome these challenges and really embrace these nature-based solution ideas. So, you know, like the ways that we can do this are threefold. We can conserve what's remaining, we can manage it better, and we can restore what's been lost. Now, I'm going to talk a lot about restoration and the links to blue carbon, but I don't want to lose sight of the fact that that's not the only solution. And in fact, conservation should not be lost from the forefront of our mind. It's actually the cheapest way to achieve nature-based solutions and to achieve the maintenance of biodiversity. So I just want to just briefly dwell on conservation opportunities. You know, we like to think about nature-based solutions for people, you know, protecting people. And so we did this assessment of how much nature is really within the urban footprints of the world. And what we found is that, you know, there's actually very little habitat within urban footprints, probably no surprise. But there is quite a lot of habitat still remaining in the sort of buffer zones. So if you like, the, you know, 10, if we characterize it here as the 10-kilometre buffer zone and the 50-kilometre buffer zone. And then if you look at these bars, and this is for mangroves on the left through to coral reefs on the right, the greyed out part or the shaded part are the protected areas, right? And so you can see while there's, you know, half of the mangroves associated with global urban areas in the 50-kilometre buffer are conserved, which I actually thought was pretty good when we first came to that number. You can see that it's lower for seagrass, much lower, and also for tidal flats, which are so important for bird diversity, for example. So my point here is that although I'm going to talk about restoration, I think conservation is still a huge opportunity, and particularly thinking about it if we want to embrace nature-based solutions within these urban footprints. Okay, so then to move on, we're going to talk about restoration. I'm first going to talk about some of the restoration targets. I thought it was really interesting the previous talk about those nutrient reduction targets that Bo spoke about. And then I'm going to talk about some of the barriers to achieving those restoration targets. And then I'm going to talk about blue carbon. And I'm pointing you here to session 14, which is a blue carbon session. It's got like 7 components. And there's some fabulous talks there, particularly about the new developments in blue carbon, which would be in seaweed and aquaculture. There's talks about other ecosystems, and so I encourage you to go and have a look at session 14 for some of my colleagues there. I'm going to give you a brief background on blue carbon and then talk about some of the barriers for implementing blue carbon strategies globally. And then finally, I'm going to talk about how blue carbon can help us with restoration. So this is the UN Decade of Restoration. So it's a great time to talk about restoration. And there are lots and lots of targets that have been articulated. There's the Convention on Biodiversity Archie target, which commits to 15% of degraded lands to be restored. The Global Mangrove Alliance, a very mangrove-y focused one, had a target of about 20% increased cover by 2030. But I think they're revising that target now. The Bond Challenge, restoring 60 million hectares. And then just individual countries. So for example, Indonesia, who has the largest sort of mangrove seagrass cover in the world as a country, has announced a target of increasing cover of mangroves by 540 kilometers squared, in a very short period of time. So if we look at this over time, look at what's happened to mangroves as an example. We saw this really sharp decline through the 70s and 80s with the development of shrimp aquaculture in Southeast Asia. We've seen that that decline slow, and in fact, the last time it was assessed, the decline was only minus 0.13% per year globally, although in some countries like Myanmar, it remains very high, right? So what we're seeing actually is that the global action on conservation, I think, and also, the attention to blue carbon has contributed, I believe, to this slowing as the acknowledgement of the value of these ecosystems is clear. And then on the other side, I've put some rungs on this restoration ladder and the sorts of targets that have been articulated. So you can see that actually they're very ambitious. We need to be doing something like between 1 and 1.5% increase per year to achieve anything like the original cover by 2050. All right, but my question here is, I'm not really, there are questions about how achievable this is. So I want to go on here with some numbers, right? So maybe for a full recovery, we might need to recover 80,000 kilometers square. And for me, that seems relatively unlikely, partly because there's been conversion to things like urban landscape, which is likely to be around 4,000 or 5,000 kilometers squared. Climate change. If we look at the models of the impacts of climate change, and we looked at that work earlier by Liza Goldberg to see that erosion and extreme events were contributing to losses, that might reduce the potential extent of the mangrove by something like 30,000 kilometers squared if coastal squeeze has the impact that we believe it's going to be. So that's going to prevent the landward migration of these ecosystems. The Nature Conservancy has developed a target around the areas they feel like are going to be easier to restore, which is about 9,000 kilometers square, because they've been converted since 1996. And then the climate change sea level rise models suggest that landward migration of these ecosystems might actually contribute 20 2,000 kilometres squared. Now, I don't really want you to sort of focus too much on the numbers, except that they are bigger than what has been achieved with restoration to date. So if we add up all of the restoration projects, the area of all the restoration projects that we know about, we get to about 2,000 kilometres squared, right? So there's obviously a large gap between what's been achieved and then really what we are suggesting that we would want to achieve. But these are increasing over time. So this is some work that we did with Carlos Duarte. It was published in Nature in 2020 that looked at how we were going to rebuild marine life. And this is an animation of the increasing activity on restoration around these 6 coastal ecosystems. And you can see that actually the intensity, the effort for restoration is increasing over time throughout the world, right? So this is something that gives us hope. There's a lot of people involved in this and quite a lot of resources being spent. But if we talk about mangrove restoration, then we also have to acknowledge that there has been huge failure. So if you look to Joe Lee's paper in 2009 in Nature, Ecology and Evolution, and my own commentary on that, these are, the failure is being caused by these very large-scale mangrove planting projects that have been implemented in really inappropriate biophysical conditions. And usually that means that they have been planted below mean sea level, or the mean level of the tide. So these, on open mudflats, rather than in places that mangroves might have been previously. And that's largely, I think, because of the complexities of land ownership in many of these regions where these large planting projects have been undertaken. We also know from the literature what mangrove restoration success looks like. So these tend to be relatively small projects. And the problem with that is that they have, limited impacts in delivering ecosystem services at large spatial scales. They tend to be community-centric. So this picture I've got below is a small community restoration of shrimp ponds back to mangroves, where the community members are actually digging out tidal creeks to increase connection, the hydrological connection of the tide with the intertidal zone. They're often really too small for investors to see, right? So if we're going to try and put more financial resources into these kinds of projects, then small ones are really difficult for large investors. And these ones are often not well documented, right? So with the exception of this particular and other smaller projects. The other thing that we know is that costs of restoration can be high. And so this is an example of seagrass restoration, or part of a seagrass restoration project, where the seeds float until the seed coat is removed. So before these can be spread out into Cockburn Sound, which is from Western Australia, they have to be, basically treated to remove the seed coat. So it's things like this, and I suppose there's the most expensive kind of restoration is coral reef restoration attempts. But we know that they are relatively expensive compared to terrestrial projects. So I've summed up here, I've sort of split restoration projects into large ones and small ones, and what are the benefits and problems associated with them. So small projects tend to have high costs of implementation per area of habitat. They're invisible, or can be unattractive to investors. they've got limited biodiversity and other ecosystem service benefits, but the benefits are that they often empower landholders. They're often very closely associated with community groups. They've often got effective governance, so quite flat structures, and there is often a long-term commitment to manage those projects by communities. So the large projects, the problems have been inappropriate biophysical conditions and monospecific plantings for mangroves, for example. They've sometimes got complex governance, which has been prone to corruption and limited engagement with communities. If you need a large swath of land to do a project, you have to negotiate with multiple communities often, which is slow and expensive. And these projects also tend to have large but short-term investments. So there's very little monitoring and adaptive management through time. So that the benefits of large projects is that you've got the potential to achieve economies of scale, right? And that you can achieve restoration of ecosystem services, things like coastal protection, support of fisheries over large scales. And then finally, those large projects are attractive to investors who, the way I understand it, would like to invest more than $1 million in a project rather than lots of small ones with lots of transaction costs. Okay, so when you looked at that great long list, you can sort of see that there's actually very little very little ecology or biology in these comments that I'm making about restoration. And I think there's been, like a really growing knowledge of the importance of socioeconomic factors in achieving successful restoration. So I wanted to point you to this tool that has that the Society for Ecological Restoration uses. On the left here is the wheel for assessing projects that was used or recommended for use by the Society for Ecological Restoration. And you'll note that it has things like physical conditions, species composition, structural diversity, ecosystem function, and external exchanges like gene flow, and then the absence of threats. But just this week in the SARA conference that's happening this week, so this association is meeting at the same time as ASLO, and they have added a wheel, and it's a socioeconomic one. So it's about sustainable economies and whether community well-being is achieved, whether there's been stakeholder engagement, and the equitable distribution of benefits from the project. They're about knowledge enrichment and restoring natural capital. So you can see that this is an explicit recognition of the importance of socioeconomic factors for restoration. So we've got a lot of barriers to overcome to encourage greater uptake of restoration. We need to get over short duration, small scale, low levels of investment. We've got to, reduce the costs of restoration. We've got to address the underlying threats. And this picture that I'm showing here is a woman selling mangrove timber in the Irrawaddy Delta in Myanmar. And, the threat there is removal for small, wood for cooking, and wood for supporting, cooking in the fishing industry and so forth, because there's just no other option, right? So sometimes it's exploitation, not because people really want to destroy their resource, but just because they have no other option. We need to get over some of the poor governance that's been that occurs in the intertidal zone. inadequate reporting is an issue, because it's really hard to learn when projects are not reported on, because maybe then they weren't as successful as anticipated. And of course, we need to increase the planning for climate change, and particularly sea level rise. Okay, so now I want to shift gear a little bit and talk about blue carbon. I'm going to remind you again about session 14. All right, so blue carbon, if you haven't been following the literature, is basically a description for all of the carbon stored in the oceans. But we have tended to really focus on coastal wetlands to begin with. And that's one, because they've been so degraded globally. And secondly, because they, the carbon that is there is really clear to us, I think, and clear to policymakers and others. So this is a picture of one of the most carbon-rich mangrove ecosystems probably in the world, from Belize. It's sitting within the Mesoamerican Barrier Reef, where there are 10 meters of peat accumulated on top of old coral platforms that form these mangrove islands. And so they've been, this particular picture, you can see it's been cleared, ready for, maybe they're going to pump some sand on the top and build a resort, right? And this is one of the first sort of blue carbon science that I did, was to start to look at emissions from CO2 emissions from damaged ecosystems. Okay, so blue carbon is really a term that's been developed to kind of incentivize conservation and restoration for climate change mitigation benefits and other benefits in the coastal zone. So we have intact ecosystems of carbon sink, the soils, sediments accumulate organic matter over time because they're anoxic. And then as you destroy them, you're resulting in CO2 emissions. So there are projects where you can conserve coastal ecosystems and thereby avoid CO2 emissions. Often these alternative land uses that mangroves or other coastal wetlands have been converted to have high greenhouse gas emissions. So, for example, if you, aquaculture, you can have nitrous oxide emissions, and if you impound and freshen up mangrove ecosystems, you can have very high methane emissions and also salt and other coastal wetland types. So if you restore these coastal ecosystems, you basically resume carbon sequestration, but you can also avoid these other emissions that might come from agriculture or aquaculture or whatever other land use that you've been, that the habitat was converted to. Right, so it's this idea of avoiding the CO2 emissions with damage or degradation of the ecosystem and restarting it along with avoiding other greenhouse gas emissions that forms the basis of the blue carbon strategy for conservation and restoration. So if we look about how important this is globally, we would have to say that blue carbon provides an important opportunity, but a relatively small one globally, right? So this is some work we did for the high-level panel for a sustainable ocean economy. And really, of all of the options, and here we have 6 options for climate change mitigation in the ocean, that the green one there, coastal and marine ecosystems with restoration and conservation, is actually a relatively small part of what can be delivered, right? So it's modest, right, compared to, for example, reforestation globally. But it is substantial in some countries. And I already pointed to and we'll have an example on Indonesia in a moment. And it's really high on the list of preferred options because of the valuable ecosystem services that coastal ecosystems provide, right? So it's about climate change adaptation, biodiversity, fish nursery habitats, and others. Right? So I point you to an excellent review by Jean-Pierre Gattuso and others in 2018. So in general, the blue carbon, I just picked 3 things to tell you about in terms of developments of blue carbon. The first is the IPCC guidelines that were released in 2013. And these are guidance for accounting for losses and gains in blue carbon ecosystems and the emissions and removals associated with those. So this gives countries sort of like opportunities to account for those changes. And that guidance has also led to the inclusion of blue carbon ecosystems in the nationally determined contributions to the Paris Agreement. So if you look at the bottom right here, you can see the countries that have committed to including coastal ecosystems in their nationally determined contributions. And it's not much of the world yet. That is still a work in progress. And then finally, there have been some carbon market methodologies developed. And these are such that restoration can be done and carbon credits can be generated, right, which then can be sold on. And there's some really nice projects developed in, for example, Kenya and Madagascar, where communities have changed management processes of their forests and generated carbon credits, which they have sold on, right, to companies that wish to, or individuals or institutions that wish to offset their emissions. Okay, so for example here, this is a recent study by Zhang et al. In 2021 in Current Biology, where they've assessed how the opportunities for blue carbon projects and where you can invest and where it might be profitable to invest even in mangrove, in this case, conservation, and areas where, it's investable, but it might not be profitable. But you'll see that they have stated that that blue carbon projects in Indonesia could help achieve about 2% of the country's nationally determined contribution, and that these projects could deliver a return on investment for Indonesia, right? So these are studies. This is sort of evidence that that conservation and restoration for carbon might be worth it in these ecosystems. Okay, so there are some barriers though. So countries haven't widely adopted reporting emissions and removals from coastal wetlands yet. And I point you to the International Partnership for Blue Carbon that's doing quite a lot of work in this space to capacity build, among other institutions that are taking on that task. The price of carbon on the voluntary market's very low, and I think that is a barrier. There's few easy to use methodologies available yet, and some of them have very high implementation costs. And I've got a logo there for the Australia's Emission Reduction Fund, because we're in the middle of developing a blue carbon methodology for Australia at the moment. There are risks of perverse outcomes. Carbon projects have been associated with negative impacts for communities, and I'll talk about those in just a moment. And then finally, people who are thinking about blue carbon projects really want to know about the risks from climate change. The uncertainty associated with that is an impediment. So when I'm thinking about the carbon projects, then, for blue carbon, we really have to mind that carbon projects don't exclude local people from the resource. That is that's a really negative outcome that could occur. So it's important for any projects to really consider that people need access to resources. So finally, I want to join these two things together, which is to ask how can blue carbon projects enhance restoration outcomes and efforts. So I would say that one thing that blue carbon projects do is that or carbon projects generally have very long time horizons. So often we have 25 to 100-year permanence periods. So they might really help us get over this sort of short-term investment in restoration. The other thing that carbon projects might deliver is a sustained income for communities. So we may be able to help with reduction in poverty, and particularly we might be able to do projects that support Indigenous peoples. So, you know, this has investors very excited because, you know, we've got the possibility to offset carbon emissions while providing social and environmental benefits. So one thing that we looked at, I showed you an example from Indonesia, but we've often been puzzled about whether this is going to be profitable, whether blue carbon projects might be profitable in developing nations. So we did a modelled study recently of the profitability of coastal wetland restoration for blue carbon in the wet tropics region of Queensland, where often coastal wetlands have been removed and replaced by sugarcane and grazing. So we were really looking at, could these projects deliver another income stream for landholders in lands that were suitable? So we identified about 5,000 hectares in this region that would be profitable already for restoration. So this would be for the carbon sequestration associated with the redevelopment of coastal wetlands, but also the avoided methane and nitrous oxide emissions associated with the agricultural use. And we also, you know, identified that while 5,000 hectares is profitable now, this could be doubled if we could generate funding for other ecosystem benefits associated with blue carbon projects, or we had a higher carbon price. All right, so payments for ecosystem services are nothing new, and it's been something that's been developing since the 60s. But what is new is thinking about how we can combine these carbon projects with other funding. And in Queensland, the government has recently initiated the Land Restoration Fund that encourages landholders to do carbon projects, and then the state basically will pay for the additional ecosystem services that are delivered. So that would be, you know, for biodiversity, things like cassowaries. And then there are also other existing schemes that we're trying to integrate here. And one of those is a reef credit for reduced nutrient inputs into the Great Barrier Reef. So there's a lot of exciting things happening in this space. One of the things we really need to do is to make projects that are large and less expensive, right? And one of the ideas of how to do this comes from Bob Costanza, and I'm sure there are others, but he's talked about the importance of common asset trusts, or the possibility of common asset trusts, which are new institutions that receive funds from investors and allocate to projects that communities are willing to support for a variety of ecosystem services. We could also take concepts like community forestry and stretch it out, where communities have control of their own assets, and these are aggregated under community forestry programs. And in both of these situations, there's a possibility of improved governance of those kinds of projects. I wanted to also say, when we're sort of developing these new mechanisms for doing restoration and integrating restoration with blue carbon, that the importance of demonstration projects. And this is one that's happening in Queensland. It's a large restoration project, 5,000 hectares, called the Blue Heart Partnership. And it's a partnership between local government, state government, and water utility. And they have acquired lands jointly together to form this Blue Heart that were sugarcane and that now are transitioning back to coastal wetlands. So they've been acquired as the sugar industry has declined in the region. And these three partners are actually in the game for different motivations. The state is interested in a pilot blue carbon project, and the local partners are more interested in flood control, nutrient treatment, tourism and recreation. So these are really interesting developments that are currently occurring. I suppose we really need to improve our planning for climate change for these projects, right? So there's a number of strategies, and I think the first one is like selecting your sites, the geomorphic setting, and thinking about how much elevation capital, so basically how much, how high you are in the intertidal zone for projects is really important, but could be, give immense confidence to people who are trying to develop these projects. Choices of suitable species are important. Devising contingencies for delayed recovery or extreme climatic events is important. And also perhaps using approaches to accelerate wetland regeneration. And these have been developed in many instances. And the picture there is on the right is actually a planting in Florida, where they're using salt marsh plants to facilitate the regeneration of mangroves. So there are, I think, a lot of options that we need to really explore. And I think it's possible, and this is a new paper that we've been working on, the planning for climate change for conservation in Moreton Bay. So we've looked at, we've modelled out what we think the vegetation distribution, the distribution of marine ecosystems will be in the future. And we've looked at how well the current reserves accommodate those high priority areas for biodiversity conservation. And what we find that those fixed reserves are, they're not that good right now for capturing the priority areas, but they become even less well aligned with priority areas in the future. So I think there's a lot of probably adaptive management that we need to do, and a lot of planning that we can do to look to accommodate both conservation and restoration of blue carbon ecosystems in the future. And finally, I think there's room for improved monitoring, and we really have seen some huge developments in this space. So I think blue carbon has contributed to the development of some of these new global tools for monitoring coastal wetlands, for example, the Global Mangrove Watch, which now produces a state of change map every year. And I think blue carbon offers us the potential to report on multiple targets. So, blue carbon, countries report to the UNFCCC, on their mitigation that's occurred. But there's a great opportunity to try and really align those with reporting for the Sustainable Development Goals, the Archie targets, Ramsar, UNESCO, and other frameworks that have conservation and restoration targets. So this is a picture actually of some new emerging monitoring methodologies developed by Nick Murray at James Cook University, where he's developing a global salt marsh cover, which is really exciting because currently we haven't been able to monitor what's happening to salt marsh. So you can see these images. This is actually from a site from the UK, 1999, that agricultural fields, and 2019, they're transitioning into coastal wetlands of different types. And you can see that the global change is blue is gains in coastal wetlands and red is losses, right? So that's sort of exciting new developments. So my final conclusion here is that restoration of coastal ecosystems is really important for the resilience of coasts and communities. We've got really big restoration targets, and there are a range of barriers, but I think blue carbon projects, blue carbon in general, can help us really overcome some of these barriers to restoration. And hopefully we will see more restoration in the future. And with that, I'd like to thank a lot of friends and then hand it back to you, Iris.
Thank you so much for this very interesting talk there, Catherine. Now I would like to open the floor for questions. So if you could please enter your questions in the chat box, I will pass them to our speaker. And while we wait for the questions, maybe, Kath, I can ask you already about the 2.5% you mentioned of mitigation of restoration project. Do you think that including of kind of combining with adaptation goals, because coastal vegetation can not only be used for climate mitigation, but also adaptation, would help kind of highlight the importance of this coastal vegetation?
Absolutely, Iris. I think that's critical. You know, I mean, a lot of people, well, there's so much enthusiasm for blue carbon and everybody's thinking, oh, it's going to solve everything. But the truth is, for climate change mitigation, it really does make a small global contribution. You know, for some countries, if you think about those with lots of assets, it can be a bigger contribution. But that 2.5% we calculated was really for both restoration and conservation, right? So I think it's still, the restoration of these ecosystems is still viewed as one of the most important, or, you know, like high priority areas because of those benefits for climate adaptation. I mean, their role in reducing, for example, the impacts of cyclones has been, you know, well established by Ed Barbier and his team. There was a beautiful paper in PNAS last year that showed when you have a mangrove still in front of you and you haven't cleared it, you know, you've got quite a wide band of coastal ecosystems. You not only reduce the economic losses, which was shown by changes in the night lights, but you actually lead to also increased or reduced duration of the damage, right? So the economic recovery is more rapid when you have coastal ecosystems present. So I think it's pretty clear that the importance in helping us to withstand extreme climatic events.
Yes, thank you. So we have a few questions coming in. The first question is, in what sense can restoration projects be profitable? So who pays for them, and what is the motivation behind paying for restoration projects?
So they can be profitable. I think this is one example I had for you, which makes it clear. So, for example, the airline industries have very little opportunities to offset their emissions within their own businesses because they basically fly planes, or they're less so during COVID, right? So but they still are committed to offsetting their emissions, right? So they would, for example, invest in a carbon project that is associated with avoided emissions or increased or restoration. So, for example, in Australia here, we have these projects called savanna burning projects that are organised by, or that are run by, Indigenous people on their lands, where they're reintroducing natural fire management. So that actually reduces emissions in the long run. And for example, Qantas buys those carbon credits that are generated from those projects to offset their own emissions. But in doing so, they're contributing to the livelihoods of Indigenous communities, right? So in that case, it's profitable for the Indigenous communities, and the airline is achieving its goals of offsetting carbon emissions while doing something that is has social and economic benefits for the country.
Okay, thank you. So the next question is of Roxanne Maringer. She says, thank you for providing some optimistic paths forwards through nature-based solutions. And asks, How did a large-scale project like the Blue Heart come to be? Through stakeholder-engaged workshops that allowed different partners to understand the relative benefits to them. So how did that come to be, this large-scale project?
It's actually a pretty interesting one, the Blue Heart project, because it really arose quite organically, I think. You know, the different partners were doing sort of similar things without really, I think, at first understanding it. So the first sort of start to it was actually the water utility that bought about 1,000 hectares to offset their, or as a, how we say, a buffer for their nutrient treatment plant. So they really needed some way of reducing the impacts of the outputs from the nutrient treatment plant. So they bought this really large wetland reserve or this large parcel of land to develop that as a nutrient project. But at the same time, the city council was acquiring land for flood control. And then, you know, the state was, it was about those three big partners having very similar interests, right? And then they also worked out how interested the public was in it. So they started to invest in, you know, a bird hide and a walk within the wetlands. And then they opened that about a month ago, and I think they've had 5,000 visitors in a month for the community to be involved. So it's not, you know, and this is sort of government agencies buying land from landholders. And when you're in the Sunshine Coast, it's not that everybody is 100% on board because, you know, the cane farmers are still not necessarily 100%, you know, signed up for this. But because that area of Queensland is rapidly changing from an agricultural based economy to one that's rooted in tourism, it's actually sort of less controversial, if you know what I mean.
Okay, thank you. Now I'll omit the last question, which is about poorly carried out restoration projects. And the question is, how can you get politicians to consider all factors for the projects rather than political gain they get for acting quickly on these current issues while still having a good forward progress in restoration?
I think it is a really big challenge, and it's one that Indonesia is facing right now and other countries. And I suppose that's why I think blue carbon is a really important contribution to restoration, because mostly outcomes, you know, have to be verified. You can't get a carbon credit if you don't have a mangrove, even though you said you were going to plant one. You know, so I think I see that there's been a lack of accountability in many cases. And so my point here, I suppose, is that blue carbon projects can really help with increasing that sort of accountability into the future. I know it's a really wicked problem, but I think there are, you know, growing mechanisms to try and head off these sort of rather unproductive and unsuccessful projects. But it's a big thing for us to guard against, for sure. And there are a lot of people watching what's happening in Indonesia right now.